Hello and welcome to another Plodware video. In one of my projects I wanted the ability to trigger actions in a PC program, and I wanted to do that with external switches, and that the ability to trigger these actions is independent of which program currently has the keyboard mouse focus. One solution would be for the program to regularly read or poll the state of the external switches and then trigger the appropriate actions. Another approach is to let the program sleep until the operating system detects or is somehow informed of switch activity. Then the operating system wakes up the program to handle the activity. This video is about the second approach. An external device monitors the state of a set of switches and reports changes as MIDI messages over a standard USB protocol. The operating system reads the MIDI messages and passes them to an event handler in the program. This video focuses on the event handling in the PC program. A second video will focus on the external device that monitors the switches and communicates changes to the PC operating system. Right, let's run the demo. We'll need to get the executable up and running. There's the executable, about 165 kilobytes. Start the application. Move this window out the way, we won't need it anymore. Put this into a corner. See what it's offering us. It's telling us what MIDI sources it's got, currently none. I've got two MIDI sources, a commercial keyboard and a Arduino based MIDI controller. Let's plug in the commercial. There we are. It's telling us a PNP device has been added. If we ask which sources, it's a Swissonic Easy Keys 49. Let's plug the other controller in. Another added device message. This time we've got an Arduino Leonardo. It always reports Leonardo on the software in this controller, even though it's a Pro Micro. It's to do with the MIDI driver being, I think, general purpose and was written originally for the Leonardo. Never mind. Would be nice now to have select an input, the Swissonic keys, and let's get a camera focused. There we are on the keyboard, and let's simply press a note. Success. Press a G. And we also have written the driver to, written my program that when it catches these MIDI messages, if it's a rotary device, a rotary potentiometer that's being altered, it checks what it is, and if it happens to be a certain rotary device, it will change the default instrument being played. Now I've set it up so that this rotary device, you can see how it changes, how it gets reported. We're currently on device 11, instrument 11. Let's play a C. All right, change it again. 51. Okay. Now let's clear the screen. Let's change to the Arduino device. Change the camera so we can see what's going on. There we are. We've got 5 buttons, 2 rotaries. One rotary sets the instrument. The other is just reported as a variable potentiometer, just as a value between 0 and 127. Let's press a button. Now Now let's change the rotary. It's selected instrument 28, whatever that may be. And finally, this general purpose rotary. You can see they're different. This is reported as controller 2, whereas this one is reported as controller 1. Right, that's the demo. What's left now is to look at the source code. So let's tidy up, disconnect, and move on to the source. Let's get access to our source files. Here's the Visual Studio 2022 solution. Let's start it. Up it pops. There's lots of files because I have written my own GUI handling, but they're not relevant. It's also written in this version in plain old C, but using it was compiled as C++, so that I had the extended or improved error handling and type handling, and then I reverted the build command to be build everything as C with, I think, 3 minor changes. That worked fine. So you can have this code running as C++ or C. All you have to do is change the compile command. Let's have a look at the source files. As I say, there's quite a few of them, but the only one we're really interested in is the MIDI C. There we are. This is the one that actually does all the real work. In total, less than 320 lines. The important bit, it's reasonably well commented. The important bit is here, the MIDI init, where we get the, we have our, when a Windows message comes in, it goes to our own little message handler, which is just a big message number lookup table. And we're telling it that if it receives the message numbers, which equate to mim error, mim data, long data, they're standard MIDI related messages, to associate these messages with our own message handlers. And then we go to the menu bar, and we've created a MIDI in sources menu. We've arranged that when that menu option, the MIDI in sources, is selected, or that it calls our own event handler, which will then ask the operating system which MIDI devices we've got, and it will build the message handler for us. And just for fun, we'll by default open the MIDI out device 0, set it to maximum volume, set it to a particular instrument, and instrument number 3 as default. And then when a MIDI message comes in, it'll get passed to our routines, but we still have to specifically open the MIDI device. This is the code that lists the MIDI sources for us in the menu. It's reasonably commented, and for each entry it'll create a callback for that particular menu V, or vertical menu element, to one of our device handlers. And when they all use the same device handler, or menu select code comes to here, says, all right, was this MIDI device already selected? If so, deselect it. If it wasn't selected, then select it. And if it selects it, it'll then call an internal function, MIDI menu open. We've almost finished already. Menu MIDI open. is a small thing that calls the operating system API MIDI in open. And if that's successful, MIDI messages will be routed to us. And when they're routed to us, they come in as MIDI data. Here is our MIDI data handler. Just for fun, echo the device to the output. Read the MIDI bytes. It's 3 bytes in a standard MIDI message, and decode them. 80 is a message off, 90 hex is a message on, and B0 is the controller, which is where we redirect the default controller, if it's controller 1, to set the output instrument. That's it. The only thing that's vaguely worth mentioning now is the USB change module. This is the code that in the operating system says if there is a plug-and-play USB device plugged in or unplugged, please tell me about it. Please tell this function or callback routine. Here's my callback routine, and it simply prints on the screen device added or device removed. That's the source code. Sorry, there's a lot more to the source code in the sense of GUI handling, but we don't need that. The important thing here is to focus on what we need to do to get MIDI messages in and then respond to them. That's it. If you want the source, then you can have it. There are, as always, a few limits, and basically the limit is if it works, fine. If it doesn't, it's not my fault. There is absolutely no guarantee of functionality. You can take the source code, play around with it as much as you like. Just don't imply that there's more of a guarantee than it might work, it might not. It might damage something, it might not. I accept no liability. Where can you get it from? Well, if you go to my website, ripetech.com, there's a downloads and script files page. Go in there and hunt for whichever demo you want. The demos will always be set up as zip files. Download the zip file, unpack it to where you want it, and then the rest is up to you. Hope you've enjoyed it. My thanks until the next time.